All right. Good morning, gentlemen. It is Saturday, February 10th, 2024. Pete, what's the number?
SolderSmoke 250. Crank it in, Robert. Crank it in, Ralph.
Holy cow! Crank it in, fellas. This is like a milestone.
The date.
250.
The
It is.
date. You got to
Huh?
put the date in there. You got to tell them the date.
Oh yeah. It's Saturday, February 10th, 2024.
Yeah, we got criticized for not saying that, and people said, I don't know which one it is. There you go.
Oh, now you know. There you go. All right. Hey, listen. We have somebody else with us today for the first time. Pete and I decided we were looking ahead at 2024. We decided to jazz it up a bit, to raise the level of the SolderSmoke podcast. And we decided to have additional people come on with us. The first one we have is our good friend Dean KK4DAS, who is located just a short distance from me over there in Great Falls, Virginia.
Great
And
Falls.
I'm sorry?
It's Great Falls.
Great Falls. Yeah, it's great over there. And so Dean is our first victim in this endeavor to expand the SolderSmoke universe. So welcome, Dean.
Well, thank you so much. It's great to be here. I'm really enjoying, looking forward to it.
All right, it's going to be cool. We're going to start off with some really good news. And there has been some good news in the SolderSmoke world, because just in the last couple of weeks, we've received reports of new homebrewers having success with what I think is the hardest part of radio home brewing. The hardest part of radio home brewing is building the receiver, getting that receiver to work, to get it to inhale, to actually receive ham radio signals. This is what Dean and I were trying to do with the local high school students, but it was close, but no cigar really. But recently, three different radio amateurs out there have sent us reports of success with receivers. First is our good friend Armand WA1UQO down there in Richmond, Virginia. He has built a really beautiful regen receiver with an amazing front panel, amazing finish. And he's got it working. He's got it inhaling. And I put up on the blog kind of the recording of this receiver in action, kind of a band spread on 40 meters. Really beautiful work. Then this was especially gratifying, I think, for Dean and for me. Scott KQ4AOP down in Tennessee has put together a really beautiful version of the high school receiver project that we worked so hard to get together to give to those students. He took our schematics, took the parts diagrams, took the BOM that Dean prepared, everything, and built this thing. Now, of course, we always emphasize this is not plug and play radio. So it took him a while to get it going. And we kind of were able to coach from a distance, because he was really good about sending pictures and documenting what his problems were. And one by one, we got the problems squared away. And then just like last week, he sent us videos of this thing inhaling, and it was really amazing. He went from the low end of 40, and you started to hear CW, then you heard FT8, then you heard sideband, and then he got up to the top, and you could hear our old nemesis, Radio Marti. I know, Dean, that must have brought a
Good memories.
good memories. We'll always have Radio Marti. Anyway, so that was there. But what I think the particularly great thing about Scott pointed out that this is the very first time he had heard amateur signals of any kind. He had never used a commercial rig, never used a commercial receiver. This was his first exposure to ham radio signals. Now, I said, wow. I said, building a receiver puts him ahead of 95% of all radio amateurs. But doing it that way, making it the very first, he might be the only living radio amateur, I think, who actually can say that his first signals were from a completely homebrew rig. He also said that he wants his first contact to be with completely homebrew equipment. So this guy really has the homebrew ethos deep inside him, and we wish him a lot of luck. He's going to learn CW. He's going to build a CW transmitter. He's going to get on the air with that with the direct conversion receiver. Fantastic! Congratulations, Scott. And then finally, I want to mention another home brewer who has done something really outstanding, Mike AG5VG down in Texas. Mike has been home brewing BITX 20s and 40 meter versions of the BITX 20. And he is taking to heart Farhan's suggestion that once you get the receiver circuitry done, pause, stop, and enjoy a few days of listening to the receiver that you've built yourself. And that is really good advice. And it's amazing. Mike in Texas has sent us videos of his 20 meter rig and 40 meter rig inhaling, bringing in signals from those bands using the BITX architecture. He actually uses a lot of the techniques that we use. He's got like pine boards underneath the whole thing. He's got Manhattan style boards kind of screwed down onto the pine board. He's got plywood boxes around it. I saw this and I said to myself, I am not alone. There's somebody else out there.
Yeah, there you go.
Engaged in this lunacy. Anyway, it's really great to see these guys doing it. And I think I just want to say something. I think that this should be kind of a spur to home brewers out there. There's a lot of guys who are on the fence who are saying, I'd like to do this one day, and maybe one of these days I'll be a home brewer. No, you can do it. And take inspiration from these three guys. At least build a receiver. If you build a receiver, you will be breaking this definitively into the ranks of home brewers. You will have done something that radio amateurs for a long time believed that could not be done. Even the ARRL discouraged the construction of receivers. It was, I think, a terrible mistake. But anyway.
Scott, if you remember in his first email to us, said, well, I saw you were working with high school kids, and he's an older fellow like us, and he's like, well, I thought if the high school kids can do it, I should be able to.
I think it's the other way around. I kind of hope that some of the high school students see this thing and sort of blow the dust off those rigs and get them working.
I sent the link to their teacher.
Excellent. We want to do it. Hey, all right. So we've got a lot of ground to cover because it's been a while, Pete, since we did a podcast. Yeah. But we got a lot of stuff to cover. So, Pete, let's turn it over to you and do your bench report first, Pete.
Well, you said this is the kind of the first thing. You prefaced your comments. The first thing, I almost would put the first thing is to have a BFR of 0, and that goal is a burnt finger ratio from solder. You should start off the day and say the BFR for today's goal is 0, that you don't solder your fingers together.
Well, I don't know about that, man, because I think it adds to kind of manual dexterity,
Right. Well, I haven't, of course, my time is very, very limited, and I have just not a lot of time like you and Dean have to maybe actually melt some solder. So the blogs recently have been to kind of look at some of my past projects and kind of highlight some of the stuff that I published that might be of some use today. And believe it or not, I found out that I had some projects in QRP Quarterly that have analog VFOs in them.
Pete, I was really pleased. I thought that was really big of you to do that. I know you were doing it in part for me, and I thank you for that.
But there was one was interesting, and I had forgotten I'd done this. I showed 2 techniques for expanding what you can do with a varactor-tuned oscillator. Typically, you bias a varactor diode, and it gives you sort of a limited tuning range. And the 2 techniques, I had forgotten about this. One of them is to use a diode doubler, so it's not an active device. You're not introducing any weird signals in there, but it's just a simple diode doubler that you get twice the frequency. And the other one was something from Lou McCoy, and it's kind of amazing you don't see too much of this. But McCoy took a dual gate MOSFET, and on gate 1, he hung a crystal, so it made it a crystal oscillator. And then he introduced a low frequency varactor tuned signal into gate 2. So the DGM is acting as a mixer, and you get the output. So one of the things you got to worry about, of course, having some sort of a filter on the output of that, so you limit just the either the subtractive or additive mix. But I've forgotten about that, and I'm saying, okay, so how would you do that today? And 2 J310s.
There you go.
Can be configured as a dual gate MOSFET, And that might be an interesting technique for getting a very stable, lower frequency signal. And the case I used was 11 megahertz crystal, and I think a 3 megahertz, 3.5 megahertz, or 3.8 megahertz reactor tune signal, and that mixed down to 40 meters. Actually, probably a better choice today to avoid unwanted mixing products like second harmonics and things of that sort would be to use a 12 megahertz crystal and a 5 megahertz reactor tuned oscillator. And the subtractive mix gives you 7 megahertz for 40 meters. So just not a lot of parts. So there are just some things that can be done. Now, behind me and at an angle is the output and I did this on purpose because normally when I do it the right way, my head is in front of the picture. so you can't
we're
see
conquering
it.
the technological challenges here on SolderSmoke. Look at this. Pete's doing that.
With
right,
pop
good.
art. I like it.
Well, what this is a quadrature output from SI 5351. In other words, you're seeing the trace from clock 0 and clock 2. And what's of interest here is if you're building any kind of phasing type of stuff, you always need that quadrature signal for the LO. And it took me a little while to get here, but of import, and we're going to get a little yawning here, guys. Oh yeah, I've done that with an Arduino, not a big deal. This is with the Seeed RP2040. So this is kind of a something that's taken the place of the Arduino, although it's programmed with the Arduino. And the feature of the Seed is that it has 133 megahertz clock rate versus like 16 for the Arduino. And it's a much smaller device. It's about half the size of a Nano. Doesn't have as many pins, so people might find that as objectionable, but it's built on the same structure as the Raspberry Pi 2040 used in the Pico, and they're only about $5, so it's competitive price-wise with the Nano. So the trick was get this work, and I didn't do this all by myself. First time I got some help from Todd to get just a basic LO BFO with the Seed, and part of that was there's a little magic. You can't just say pin D2 or pin D3, you actually have to use the pin number, which is like 27U and 28U on the device when you specify it in the sketch. You can't just say D2 or D3. And there's some other functionality things. So I did get some help from Todd and got the basic BFO. And then Bob Nichols, W9RAN, interesting guy. He provided some quote Seed, SEED code for a quadrature application of the SI 5351 with the Arduino. And it was just a snippet that says this will produce a quadrature. And then he had a loop counter in there that incremented the frequency by 200 hertz every time you went through the loop. So you could look at the serial monitor and say, oh yeah, it's changing the frequency. Then he says, if you want to build a VFO, it's up to you. So I had to take that snippet and plus what I got some help with from Todd, and I generated this quadrature signal. Now, something really fascinating here, and you can see this on my blog, N6QW.blogspot.com. So you always want to look, and the typical approach has been if you've got like two audio signals, you can put them into the X and Y input of your oscilloscope. And if you get a perfect circle, you know there's a 90-degree phase shift. Perfect circle, 90 degree. And as a matter of fact, there's something interesting you can see on the internet. If you get an ellipse, depending which way the ellipse is, tells you whether it's 45 off or 135 off. So you can just look at the picture and say, oh yeah, it's not 90 degrees, what you would like to have for phasing. So I just took this picture and I posted it on the blog, and I said I did not get a chance to look at the XY inputs, but I should get a perfect circle. So after I posted it, I said I better do that because someone's going to start bitching. Oh yeah, you didn't post a circle. I want to see that. So I plugged it into the X and Y, and I didn't get a circle. I got something like this. And
I
then
saw it.
the
So the picture was really cool.
The light bulb went on, It's a square wave.
There you go.
What you're producing out of the SI5351 is a square wave, not a sine wave. And in fact, I'm getting a 90-degree shift because I have a reference in there that when you put either a triangular wave or square wave into the XY inputs, it'll tell you whether it's a 90-degree shift or a 180-degree shift or what have you. And if you get a device that looks like a square, but it's lopsided, it's not normally a square like this, but it's vertical, you got 90 degrees. So I said, okay, it's 90 degrees. But I learned something that I had immediately assumed I should see the circle, but that's only good for sine waves. So if you're putting any kind of other signal in there, and the reference link has one graphic, just print that graphic because it'll show you the various degrees of phase shift. So that is a 90 degrees phase shift, SI5351 with a Seeed RP2040, and it is 90 degrees. So if there's some application that you need to do that, I did some hard work to make that work.
Well, congratulations, Pete, because I remember a while back that there were a lot of problems getting 90-degree quadrature out of the clocks of an SI5351. And for a while, people were saying it wasn't possible, but obviously it is. The other thing in terms of measurement, I mean, I was really jealous of your nice circular and square patterns and everything else. But I kind of just took the easy way out, because the Regal scopes that we're using, if you go into I think it's the math function.
Yes. It'll
give you the exact kind of phase relationship between two signals. And at one point, I started out with a divide by 4 generator, but that would limit me to the lower bands, right? And then I figured, well, I know what I'll do. I'll go divide by 2, and that'll allow me to go up higher. And I did it, but I noticed that this opposite sideband suppression was a lot worse with divide by 2. And when I looked at it on the Regal scope, sure enough, it wasn't quite 90 degrees. It was 88 degrees or 89 degrees. So I retreated. I went back to divide by 4, but you're way beyond that. You got the circles and the squares. Pretty cool.
Yeah. Well, like I said, I learned something. You hook it up and you say, "Oh crap, there's no circle." And then I said, "Wait a minute, it's a square wave that's going in there." So that's why you get in it, and it is 90 degrees.
How do you pronounce that word? Lysagius?
I'm not sure.
But, I don't know, but you see it all the time. And I always wonder, a lysagius pattern. So we'll have to turn it over to the community. Are we pronouncing that? Am I pronouncing that correct?
It's not Lisa Juice.
Listen, I thought it was Lisa Juice.
She makes great juice.
Yeah, there you go. Okay, one final thing is, I've got to grouse a little bit about something that I ran into from the ARRL and their projects. Anybody get a project from ARRL, never trust what you see in the schematic. Couple of podcasts ago, I displayed my revamped shirt pocket transceiver, shirt pocket transceiver, and in its original form, it was 16 cubic inches, and I said, I want to build something to rival what Ben Vester, W3TLN, did in 1963, because he built this really small 7x5 by 2 inch transistorized 20 meter single sideband transceiver, and totally homebrew. And there's a picture in the magazine article with a D104 up here in the box here.
Really, really a cool article that has appeared over the years in SSB for the radio amateur. I've got 3 different editions of this book. And every time I would be looking through it, I'd see that thing and think, wow, that is a really cool rig that he did way back when. I want to build one of those. But you actually did.
I did, and it didn't work. And it drove me nuts why it didn't work on transmit. Why wasn't it working on transmit? And I mean, I reviewed all the circuitry and looked at everything, and at the time I was preparing the article for the shirt pocket transceiver, I happened to mention to the editor of QRP Quarterly that I was doing this, and I said, I never could get Vester's project to work, and this is what prompted this. Say, screw that, I'm going to do my own. And I said, I got mine to work, and it was not anything like Vester's, but I said, I still don't understand. He said, well, let me send you the original article. Because what I was building it out of the sideband handbook. That's what you're talking about, the sideband handbook. And I looked at the original article and the sideband handbook, and it's not the same schematic. There's an error in the schematic that you're grounding one of the connections, is essentially shorting out a coil and shorting out the input. So you won't get anything coming out of the transmitter.
Was there ever an errata published or anything like that? Did anybody ever?
No. And so now if you build it per the original 1963 article, it'll work. But if you build it per the sideband handbook, it won't work. And that was not the first time I ran into a major project. I built a 3CX800 A7 linear amplifier. And when I started getting into some of the parts, like building the RF choke and some of the wiring, it didn't make any sense. And so I said, I'm not talking to the ARO. They had the author. So I wrote the author, and he says, oh, yeah. He said, well, let me tell you about that. He said, I built the amplifier. I sent it to the ARRL lab with the article. And he said, didn't hear anything. He says, then I opened up the QST, and there's my article. And he said, they reworked the rig, and they reworked the article, and they published all the values. And he said, you're right. You cannot build it per that article. There's stuff missing out of there. And he said, if you built it that way, you're at risk of smoking something. I said, they never contacted you and asked you about this? He said, no. He says, never did. And he said, I get a lot of mail like yours saying, hey, what about this? So if you're looking at QST, everybody puts it on a pedestal. Look at it with a jaundiced eye saying, is that really correct?
Yeah, look what I have up here. Up here, I'm pointing to it right there, up above my head, up above the HW101. And that is the Hearing Aid 5 receiver that I bought at Winterfest 1 year ago. And that's what launched me on this whole effort to find out what was wrong with the receiver. And we just kept we found two major errors in the schematic and with no erratas. Also, I got in touch with, like, as you did, many people, several really experienced home brewers wrote to me and said, as a kid, I tried to get that thing going too, and it wouldn't work. It just wouldn't work. The other thing I found out was that even if you did take care of all the problems, it's still a lousy receiver. It's still terrible. It's much worse than the one that Dean and I did for the high school. And the one Dean, the high school is really simple, but it's very effective. This thing is simple but ineffective.
Yeah, a couple of things though, Bill. First, schematics. So having gone through this experience where you and I tried to draw a schematic of our simple direct conversion receiver for the high school kids, I feel sympathy for the editors and drawers of schematics. And
it's hard.
What I've learned is just take them all with a grain of salt. Even the ones Farhan publishes have errors in them. So you have to, as a home brewer, you got to take a critical eye. Of course, when you're starting out, you don't have a critical eye. It all just looks like a bunch of lines and wires.
Especially when the article is entitled "For the Beginner," right?
The beginner, yeah. And then the second thing is, since I got started in this hobby much later than either of you, I have the benefit of all of this, the internet. So I contacted you when I first did my first transmitter. I contacted Pete when I wanted to do the SSB. I've been in touch with Farhan. It's so much easier now because you can write to the guy that wrote the article and they'll write you back and say, yeah, you got to fix this, or this is this other thing.
It is a lot easier now. The other thing is, when you find, if your work is published on the internet and you suddenly discover there's an error, you can correct it literally in seconds. You go click, 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 change the part number, click, upload, boom, it's done. And henceforth, everybody who looks at it will see that it's corrected, which you could not do in 1976 in QST. Once the thing went out, now you could fault them because there was a possibility of doing erratas. And a lot of these articles you'd find a couple months later, somebody would say, oh yeah, R16 should be 100 ohms, not 10K or something like that. But for a lot of these rigs, they found errors and then just for one reason or another did not publish erratas, or even worse, went on to publish new versions of the rig, like the SSB rig, with new errors in it in books that were repeated over the years. So
Yeah.
I'm down on them too. Yeah. Boo.
Have you heard anything about this new approach to QST with the subscription? I heard a few comments on 40 meters. Guys were grousing about that. You don't get a hard copy anymore. You
I,
spend
well, I don't
49 or
know.
59 bucks.
I
And
don't
you
know.
got to download it.
Yeah, it's kind of weird. It's kind
Yeah,
of strange.
crazy.
It's changed a lot. I remember when I first started writing for QST, one of the reasons that you would want to publish in QST would be that you would know that automatically they were going to print out 175,000 copies of this thing and mail it all over the world. That's a lot. I mean, that's a lot more than you'd get from a typical even book publication. But I don't know if they're doing that much anymore, because I think, there's a lot more available. People are reading stuff online, and the old style magazines, a lot of them are folding, so I don't know.
So that's my limited time.
There you go, Pete. Thanks very much. Dean is going to share with us, I think, a tale of woe. Our listeners like to hear tales of woe, Dean.
Maybe more than one. So
woes.
So the title of this segment, if we're going to title our segments, is Hallucinations, Ground Bounce, and Wisdom.
And I told Dean, I said, that's going to be the title of my next book. It's going to be Ground Bounce, FFT Hallucinations, and Wisdom Files. Why I have struggled against digital VFOs all my life.
Well, I'm not sure that this is going to reinforce that or not, but that's going to be the title of the segment. So what I'm doing is I am attempting to build a homebrew version of Farhan's sBITX. This is the SDR BITX that he came out with 2 years ago. And when he published his first article, he said, "This is simple. The one page of code does the entire SDR function. You can take this digital thing and hook it up to any analog radio and it'll work." Well, I had already built an analog radio, Pete. I built the simple SSB, and I actually had the IF module from the simple SSB, my first one, sitting in the box that Bill has come to call boards that might someday be rigs. So I had a board. I know how to do Raspberry Pis. I know how to do SI5351s. The little magic thing that this thing needs is something called a codec, a encoder that does the analog to digital and digital analog conversion. And Farhan's architecture is really quite elegant. I mean, you have an analog front-end receiver with all the things that you normally have. You have a front-end filter, and you have a crystal filter with diodes, with mixers on either side. And then out of that comes what he calls a preamplifier, which is a 24 kilohertz IF, which is what you feed into the audio, and that eventually gets processed in the software, and out comes this beautiful waterfall display. And you get a nice, beautiful, and not a lot of parts. But the first problem is you got to have a 40 megahertz, 25 kilohertz wide crystal filter. And I had never built a crystal filter. And Pete, your first guidance to me when we were building simple SSB is don't build filters, it's too hard. And I think what you meant was don't do that first. Do other things first. Use a commercial filter. Save the hard stuff for like, well, I'm several years down the road now. So I very quickly built a 9 megahertz filter and plugged it into the Apple SSB and said, yeah, I got that. I know how to build filters. Then I got some 40 megahertz crystals from Mauser, and I built the thing, and the typical filter profile where you've got kind of this upside down U shape, and then you got this sharp vertical on the top end, and it drops off at like minus 90 dB. I was getting only like minus 40 dB stop band, ultimate stop band, and it's like, well, that's not right. That's the filter the shape looks right, but the stop band doesn't look good. And I was tearing my hair out, and I built like 3 versions of the ZIFs, and I went to Farhan. He said, well, you're using overtone crystals. No, I wasn't using overtone crystals. I wrote to Dave Gordon Smith, G3UUR himself. Again, a great hobby. And he came back to me and he said, I don't think you can build a filter with 40 megahertz crystals, because he hasn't built one in a while. I said, oh yes, you can. Farhan's got them. He uses these tiny little surface mount things. So I start thinking about, all right, is it the fact that Farhan's using surface mount, but I'm using ones that are a little bigger? Is it that the cases are not grounded? I went through all of this stuff, and you know what it was, Pete? I was using the nano VNA wrong. There
you go.
I had taken SMA leads and I built some alligator clip leads to attach to the SMA leads, and I was using the alligator leads to connect to the filter. And Farhan looked at the picture. He says, get rid of those alligator leads, put SMA connectors on there, connect it directly to your SMA, because you're getting straight capacitance and inductance in there, and you're changing the timing, and that's a sensitive device. And as soon as I did that, the filter looked perfect. So I have 3 perfect 40 megahertz, 25 kilohertz wide filters.
Welcome to my world, Dean. This means you're going to ultimately have to build at least 3 of these transceivers.
So that was my first tale of woe, and it echoes a lot of things that you guys talk about all the time. Know your tools, know what you're looking at. And you mentioned it before when you're talking about the quadrature. You're looking at the output of this thing, you're saying, well, what's wrong with it? Well, you got to know how to interpret what the device is telling you. Otherwise, you just spend your time. So that was kind of tale of woe number 1. So I have a perfect filter. Getting the digital part of this rig built was not hard. Raspberry Pi used a 7-inch touchscreen display. The Raspberry Pi plugs right into the display, so that's pretty easy. The audio codec I had to order from Microelectronica over there in Eastern Europe, and it came via DHL, and first one didn't work, so I ordered a second one, and it worked. Started producing audio, and then an SI5351 for the clocks. Well, in Farhan's article on the digital board, he gives you a caution. He says, make sure that your only ground to the digital section of this is from the power supply. Run a direct ground line from the power supply, and make sure you have no other ground between the digital portion and the analog portion. Now, I put the SI5351 on what I call my digital board, and I said, well, I got to put like coax between the SI5351 and the mixers.
Oh.
But Farhan said, don't have ground loops. So I only connected one side of the ground, and I left the other side open, which is what you do for audio, right? Well, turns out that was not the right answer, because that created something called ground bounce inside the SI5351. And I was getting all of this crossover between clock 1 and clock 2. I was getting both signals on both clocks.
We saw this. We said, this can't be right.
This cannot be right. This cannot be right. And I swapped out. I thought, do I have a bad SI5351? And I swapped that thing out. And and it's like, and I built this SI5351 circuits 5 or 6 times and never had a problem. And then we started going back to the old articles about leakage between them. Well, this was not just leakage between the ports. These were full-blown signals coming across both. When I started debugging with Farhan, he took one look at it and he says, I think you have ground bounce. I'm like, what's ground bounce? And he sent me basically a detailed description of what happens inside the SI5351 chip if the ports aren't properly grounded. And he says, no, you have to ground both ends of the SI5351. I said, well, but you said don't put grounds on the digital board. He says, well, I don't have the SI5351 on the digital board. I have it on the analog board. I said, okay. So I removed the SI5351 from the digital board, put it on its own little board, separate power supply, grounded it to the analog, put good coax on there, ground bounce defeated. So now I could get the radio tuned, and it receives beautifully. It's wonderful, great sideband. I can decode FT8. All of those things are great, except the frequency display is wrong. It's wrong in weird ways. At 10 megahertz, it's off by 200 hertz. At 7 megahertz, it's off by 300 hertz. At 5 megahertz, it's off by 500 hertz. Nothing rational about it. So I have spent 2 or 3 weeks just trying to figure out what the heck is wrong. And this is where, again, the international part of this thing, Farhan and I have been on, he's in Hyderabad and I'm here in Great Falls, Virginia. We've been on WhatsApp mornings and evenings when he's not sleeping and I'm not sleeping, and doing kind of these intercontinental debugging sessions. And he got stumped. And he kept saying, well, I think it's probably your test equipment. Don't trust the frequency counter on your Rigel scope. Don't trust that Chinese signal generator to produce the right signal. Don't trust the tiny SA to put a signal out that's exactly, you got a calibration problem. You got a calibration problem. Well, I tried everything. So finally, I eliminated as many of the variables as I could. I don't have an antenna in my garage workshop. I have the antenna up here in the shack where I operate, but I don't do soldering up here. So I do the soldering and stuff downstairs in the garage. So I disconnected my station antenna and I ran it into the garage and I connected to WWV. So I knew I had a good 10 megahertz signal and a good 15 megahertz signal. And I could see that it was making that shift. And I knew where it was supposed to be. And if I'd adjust the BFO so that the 10 megahertz signal was perfect, dead zero on the display, it would be off at 5 megahertz. It would be off at 20 megahertz. It was just tearing my hair out. So Bill said, all right, let's start eliminating things. So I got rid of the SI5351 and I used an external signal generator to generate the 2 clocks. Same problem occurred. I then said, all right, I don't know what else to eliminate here because I've been doing, I did all these measurements. I wrote all this, I collected lots of data and none of it was making any sense. So Bill's last suggestion to me was, well, can you just put like whatever's supposed to go into the audio codec directly into the audio? So I disconnected my entire analog radio. I got out the AD9850 signal generator that I built, like the very first project I built with a Raspberry Pi, set it on 24 kilohertz, which is dead center of the passband of the IF, and just plugged that into the audio input into the codec. So no analog radio at all, just a 24 kilohertz sine wave going directly in. And you know what? It's 500 hertz off. So I wrote back to Farhan. I'm like, what do you think? He says, maybe it's the crystal in the audio codec. So
yeah, there you go.
There you go.
The problem here is that Farhan has chosen this WM3871 codec chip, which went out of production in December. And he has, a big reel of them. He'll have as many for as many sBITXs as he wants to build. And he builds his own, codec board with his original prototype. But then in the production sBITX, it's built into the board. So there's no separate board. He said, well, just get the prototype board from Microelectronica over there in Eastern Europe. So that's where I got it. But of course, if they can't get chips anymore, they're not going to make more of these boards. So he said, well, I have some that I built for when I was doing the prototype, and I'll send you one of those. So he's sending me a VU2 ESE built prototype board with an audio codec on it that I'm going to swap out the Microelectronica one and see if I'm done. But I'm still not certain that I've solved the problem.
I would just like to pause at this point and just note to both of you guys that my LC VFOs that I built, they do not hallucinate. They don't have ground bounce. They don't require wisdom files.
We haven't gotten to the hallucination of the wisdom yet.
They drift. They got phase noise.
I'd rather have them drift and have phase noise than to have them hallucinating on me. Tell us about the hallucination, Dean.
So I'll get to that in a second. Let me just finish this thought, which is that I still have a problem in that the delta between the tuned frequency and the displayed frequency varies with HF frequency, which does not make any sense because the HF part is all mixed out by the time it gets down to, you got this 24 kilohertz IF. So I don't know. I still have even after I get the right codec, I think I still have something to chase down. All right. So hallucinations and wisdom. Okay. We talked about ground bounce. So shortly after I first got the receiver working, I was listening on 40 meter and just really enjoying it. And I even tuned up to the AM portion of the band. And the AM actually sounds particularly good on this on this receiver, even though I'm listening in sideband.
The sBITX sounds great. I mean, I must
Yeah.
say it's a wonderful sounding receiver. Hats off to Farhan on that.
But then after looking at it for a while, I started looking at the waterfall, and this is where the waterfall can drive you crazy, because every time they would transmit on this AM net that they were having, I would see little peaks all up and down the waterfall. It was like I was getting all these harmonics all up and down the waterfall. I thought, well, these guys are overdriving. There's something crazy here going on. And I took a little video of it, and then I tuned down to another net, and they said, oh yeah, there's some guys a couple of kilohertz above us that they're overdriving like crazy. And I thought, all right, well, maybe that's it. But then I switched way off of that frequency, and I was seeing it all up and down the band, and I'm like, is there interference? But no, it was tracking exactly with the audio peak of whoever I was listening to. So when they would peak, all these little spikes would peak all up and down the thing, and it just looked nuts. So I took a little video of it, sent it to Farhan, and he said, that may be FFT hallucination.
Look, see this rig over here? It doesn't hallucinate, right? There's no hallucination.
Oh, I thought somebody let ChatGPT loose on our radios. It's like
It's
hallucinating.
It could reach up and grab you by the throat at any time, Dean. Be careful.
All right, so there is a technical solution to this FFT hallucination, and that is to create a set of what are called wisdom files. And wisdom files essentially tune up the FFT. They're basically a preset, and when you feed them into the FFT algorithm, it smooths it out. I don't really understand it. I read a little bit about it. It's a real thing. It's not a made-up thing.
See, Pete, you just need to get some wisdom files, my friend. Get some wisdom files. Have them ready in case the thing starts hallucinating. But if those patterns become rectangular, then you got to get some wisdom files going.
But there we are. So we have hallucinations, ground bounce, and wisdom. I have a beautiful sounding radio that has a frequency display that is off wildly depending on what frequency you're on, but I'll get there. But the good news is I have 90% of the transmitter done. I need to do a power amplifier and a little bit of switching, and I'll have this thing up and running as a transceiver really, really soon. And big thanks to Farhan for working with me. He's been really patient. When I ask stupid questions, he's very calm. I never accuse him of anything. I'm much nicer than the people on the BITX reflector. So I just ask questions. I always assume it's me. Everybody else always assumes it's him. So and then Dave Gordon-Smith, G3UUR. If you're listening, Dave, thank you so much for all your help with the filters. So that's it for my bench, Pete, Bill.
Thank you. Hey, Dean, I want to give you just a piece of information. I have a commercial SDR transceiver called the Proficio. And I have seen where it'll be dead nuts on 15 megahertz with WWV, and you tune down to 10 megahertz, and it's not zero.
Oh boy!
So
it's hallucinating, man.
Yeah. Well, I'm just saying this is showing up in other arenas, so it's not just specific to the sBITX. And I just scratched my head, so I said, okay. Well, zero to whichever is closest. If you're operating 40 meters, zero it on 10.
Well, Bill graciously loaned me his sBITX Developer Edition that came from Farhan a couple of years ago, and I plugged it in next to it just to see, is it me or is it the sBITX design? I don't know, it's me. So.
Oh man, sorry to hear that. Hey, Pete, at this point in the show, I usually forget what to do, but what you usually remind me.
Shameless Commerce Division.
It's a Shameless Commerce Division. Dean, I'm sorry, we got to do this every episode.
That's
here.
Right.
Listen, I'll try to get through quickly. Whenever you guys are tempted to buy something, a Lamborghini, a really expensive signal generator, even small stuff, just go over to the right side of the blog. I've got a big Amazon sign on there. If you click on that thing, no matter what you buy, cha-ching, Bezos sends us some money. So try to do that as much as you can. It's working. It works. Sometimes it doesn't work, but now it's working. It's there. And also, I tried to do something similar with eBay because Pete has been sending me all kinds of great references to buy stuff on eBay. I buy almost everything he recommends. I got the same kind of thing. It's the same kind of affiliate program. It might work. I know the Amazon one works. I'm not quite sure how much money eBay is going to send us, but try to do that if you're of a mind to do it. One other thing I found out, I was listening to the meeting of the Vienna Wireless Society last night. And they were talking about their Facebook page. The guy said something that made me think. I kind of promote blog articles by putting them out on Facebook groups that are kind of relevant to the subject matter at hand. If you see one of those articles, like it and forward it, and that means that Facebook will send it to more people. So more people it's better because maybe we'll get more home brewers, get more people reading the blog. It'd be good. So try to do that. Finally, I'd say become a patron of SolderSmoke. We're really blessed with a lot of good patrons through the Patreon system. I've got the links up there in the upper left-hand corner of the blog. And we put these donations to good use. We have a lot of causes and parts acquisition projects that we like to support. Yeah, go ahead and do it. So I think that's, oh yeah, finally, the other thing is very important. Visit the Mostly DIY RF website. Again, the link is on the right-hand side. Todd out there in Portland, our good friend, is producing a really impressive number of kits of Pete's PSSST.
Yes.
Transceiver, and getting great reviews for it. So take a look at Todd's site and definitely buy a PSSST kit from Todd over there at Mostly DIY RF. Really good. Hey, listen, I guess I should start talking about what's going on my bench here. I find myself building yet another dual bander BITX rig. Now, Pete criticized me sometimes because I build the same rig over and over and over again. But listen, I just got to say, I just found out that because Dean has another one of these filters sitting around, he's going to start doing the same thing. It's going to be the same thing over and over again. Each time you get a little bit better at it, though. And each time I try to incorporate different kind of parts. So you see the thing over here. I got it sitting right there. Those of you watching by video can see it. And look, it's the VFO is built around this box that was the Galaxy 5 VFO assembly. Pete recommended that I get this a long time ago. The thing is that it's got this great anti-backlash mechanism. That's the big gear there. It's actually two gears that are meshed different ways, and they're spring-loaded. So one set of the teeth is on one side of the other gear, and the other side on the other side of the gear. So you don't get any kind of backlash. So I use that, and the capacitor that's inside the box. I put a little coil in there, and that became the core of the whole thing. But I tried really just then using that VFO to reproduce the success that I had with an almost identical 15 and 10 meter transceiver that I built. When did I build it? I built it in July 2023. And you know what? I got this thing built. I thought I built it exactly the same way. But you know, this one doesn't sound as good. It doesn't sound as good as the first one I built. It's driving me nuts. This is my tale of woe for this week's episode. Look, I want to make it sound good, and it's almost close but no cigar, but then all of a sudden the audio amplifier will overdrive or something's wrong. But it's good to have two rigs, one of them that is working really nicely, because you can go back and make comparisons. I've gone as far as putting them both on the bench right next to each other and sort of testing voltage, testing output levels at each point all the way through the circuit. And I'm getting there, but it's not quite done. But I've got a good lead, so I'm pretty confident by the end of the week, I will have success, and this thing will be sounding as good as the other one that I have. Once I get the receiver done on this thing, this is basically BITX architecture, but the IF and the crystal filter is at 25 megahertz. Dean, I had a similar thing where you said that the G3UUR said that you couldn't build crystal filters that high. I had a similar reaction when I told people that I was building crystal filters at 25 megahertz. People who really know their stuff came back and said, "Ooh, I don't know, that's kind of high." But I find that they work just fine, even with 10 poles. I got 10 crystals along there. Sure, there's more loss. So what? But if there's 10 dB loss instead of 5 dB loss, you just build amplifiers at either end that boost it up and you make up for the loss. That's all. And I use the software. I use DishL software basically to tell me what kind of capacitance to ground, what kind of impedance it requires at either end. And and it's great. It's been working out fine.
Bill, I wonder if it's that the guys like Wes and others were used to using the older style crystals, and now we have these really small computer crystals, and they just operate better at the higher frequencies.
It's whatever it is, but also I've noticed kind of a difference in performance between. I have the computer crystals at 25 megahertz. I have some that come in like the taller case, sort of like the HC6U case. And then I have the low riders. I call them the low riders. They're very low to the ground. They're not SMT, but they're low profile.
Yeah.
I have actually, and this is ironic, I've gotten better results with the low riders than with the with the higher cases.
That was what I ended up with on the 40 megahertz, the little low ones.
Yeah. And I really don't know why. It's worth exploring a little bit. Another question that I'll put out, as long as we're talking about this, soldering a wire to the case to ground the top. A lot of times people will run a wire along the top of the crystals and ground it at either end. Look, I've tried doing it. I've never noticed a difference. I think, Dean, you tried it, didn't notice a difference. Pete, what do you think about that? Should we ground the crystal cases?
Yes.
What benefit does it give?
Well, for one thing, it's a capacitance issue. For instance, let's just take the case of some of these HC49U, the short can, or SMD, versus the wire. So the thing is, oftentimes guys will leave if it's a wire lead, will leave a 1-inch lead and tack solder it. So you're getting some capacitive effect between the case and the circuitry. So if you ground the cases, you eliminate that capacitance problem that you would have. And I think it makes some sense. If you use a surface mount, then you don't have to do it because it's really closely coupled. The leads are very, very short.
Yeah.
So I think.
But I mean, when you go ahead and you ground the cases, do you notice a difference? Like if you're looking at the pattern, if you're looking at the pattern, say, I hate to say it, but on an nano VNA or any other spectrum analyzer, are you seeing any kind of difference in the pattern?
It's kind of hard to tell. I mean, the pattern may look the same, but it may be a difference in the height and a difference in the attenuation, difference in the roll off. So, but typically people will tell you when you build the crystal filter, ground the cases.
Yeah, I know. That's it. We've heard this many times, but I'm curious, and I'm going to probably do the experiment where what I want to do is I want to take a look at the output pattern on the nano VNA, right? Yeah, you're holding up there. There you go. They're seeing. I'm seeing them. And then I'm gonna take a picture of that passband pattern without the crystals soldered to the board. Then I'm going to solder the crystals to the board and take a picture again of the passband pattern and see if there's any difference at all.
I think you also have to look at the frequency. Kind of what I've seen about homebrew crystal filters is they usually talk the best performance between 4 and 12 megahertz for the frequency. Yeah. Now here's part of the rationale for that. Look at your stability factor of your crystals in parts per million. Typically, the stuff you're buying, computer crystals, the less expensive ones are 50 parts per million. So that's 50 times whatever your megahertz is, okay? So the stability at a 4 megahertz crystal at 50 parts per million, you're getting somewhere around 200 hertz or so stability. You take that at times 25 megahertz, that's a bigger number. So that was part of the rationale, is the stability of the crystals in the environment you're going to use. So typically you hear the guys say, go from like 4 to 12, well, 12 being the upper end. That doesn't say you can't build a crystal filter at 40 megahertz, but depending upon your environment, if you get large temperature swings, you're going to get stability issues. So I think anything that you do to eliminate an element that's going to impact that filter, whether it's the stability by what frequency you pick, and also by grounding the cases to eliminate any stray capacitance. So yeah, you need to do that, but you also probably need to look at that, not just at one specific filter, but you may need to look at it. You got some low end, some high end, some really high end, like a 40 megahertz filter. Would be the analysis that you need to do. Is it's the range you're looking at may be okay, but in general, if you're looking over a wider range, you may need to do more things like use short leads, ground the cases, pick the right frequency. So it's not just one factor of grounding or not grounding.
Yeah. All right. Well, I'll give it a try. I'll let you guys know probably on the next podcast what the patterns look like, and also I'll take a look, like you said, at sort of performance over time to see if how these things are changing with temperature and signal flow through it.
Get your hot air gun out.
My hot air gun. Yeah, that's good. All right. I just want to wrap up my portion of it here. That's what I've been working on, and I just want to also mention we've been dabbling in 10 meter AM. Yes, indeed. And I had some blog posts, and what I did is I found an old 10 meter transceiver that I had, and then I just happened to find a Jerry Kaufman K5JC, who came up with a really fantastically easy modification to this rig that will allow it to go on 10 meter AM. Look, Dean has got his. Look, he's got his there, man. Look at that. See, I did the mods on two transceivers. One, I did the mods on my General Electric. Now, a General Electric transceiver, even though it's a CB transceiver, General Electric, they got pretty good street cred with General Electric. But I did it on another one, and I gave the other one away just because I was in part mostly because I wanted to give it to Dean. I wanted to give him one so we could establish a link between Great Falls and Falls Church, Great Falls and Falls Church, but also because his transceiver is a J.C. Penney transceiver. I mean, oh man, look at that. J.C. Penney. There it is. You could see it on the screen. J.C. Penney. Pete, I was telling Dean, the last time I bought anything from J.C. Penney, I think it was socks. Right?
Yeah.
And now they're selling CB radios.
Actually,
the board itself is not that bad. It's not that bad. So anyway, we've got that going. And so far, we have not been able to establish the link between Great Falls and Falls Church. However, on my GE radio, I've talked all the way out to the West Coast, and I haven't worked in.
And I've had one-sided QSOs. I've heard a lot, but I haven't actually spoken to anybody.
Yeah, you're going to do it soon. You're going to do it, and we're going to modify more of these things. Hey, we got to wrap up because we're approaching the 1 hour point here. But one thing I wanted to mention is counterfeit chips. There was I think it was the IMSI guy did a thing on counterfeit chips, and he broke them open and took. We still don't understand what is the economic rationale for going through all this trouble to sell counterfeit chips. They're basically taking cheapo op amps that they have available in large quantities and then repackaging them to make them look like Texas Instrument higher quality op amps and then selling them. What do you think?
Because there's millions of hams that are going to buy those cheap Chinese op amps.
How many millions of hams could be buying?
These are 10-cent parts. So
I know they're 10-cent parts, and maybe the inputs would only cost you 8 cents instead of 7 cents or something like that, or 7 cents instead of 8. It just doesn't make any sense.
It's
I don't know.
It's a cultural thing. It's a cultural thing. You never admit that you build something bad. So instead of building it bad, you repackage it and sell it.
I don't know. I thought we had come up with like a rationale where parts weren't making specs and they were like kind of on the factory floor, and somebody swept them up, and instead of throwing them around, throwing them away, they put them in a bag.
These are legitimately different circuits inside the IC, and there's a guy that's basically does very high resolution imagery of these chips. They take the plastic off the top and they image it, and sometimes you can even see the part number etched onto the die.
That is not the one on the outside of the package. So please, if anybody has figured out why this makes economic sense to do this, or how anybody's making any kind of money on this thing, I don't know. It's still a bit of a mystery.
This has a long history to it, Bill. The Raytheon CK722 that I cut my teeth on, first solid state device.
Yep.
Were actually Raytheon CK768 that didn't pass the spec test. so they took the CK722s.
Maybe we're being too harsh on the Chinese manufacturers. Yeah, Raytheon was doing it right here.
So they used to do that with CPUs.
CK722. They were CK768s that didn't pass spec. And they said, well, what are we going to do this? Well, we'll sell them to consumers. hobbyists.
Intel used to do that with their CPUs, right? They'd test them,
Yeah.
and whatever clock they tested good at, they'd sell them as that clock, and then they downgrade them and sell them as at the lower clock. So sometimes you could buy an Intel CPU and overclock it, and it would actually still work pretty good because it was the same chip.
You guys are pushing me further into the analog discrete component BJT world.
BJTs are some of them are phony too, and
I know. I'm starting to find out. It's terrible.
Hey, something I forgot to mention in my segment, and after posting on the blog about the quadrature SI5351, I've gotten some emails that the RP2040 guys in Europe have figured out how to eliminate the SI5351 and get into the PLL of the RP2040, and they produce the signals directly just by doing something with the software and getting into the PLL. So they said, in the future, maybe all you need is just the RP2040 and not an SI5351.
This is a great segue to the mailbag, which we're going to do right now, because the first one I'm going to mention is Mike WN2A, who always provides really astute comments. He was all for my lambasting of the SI5351, because you know how lambasting I have been.
Yes.
But he said that there's another reason to be hating on the SI5351, something that you guys, you especially, Pete, might not be aware of. Do you know there's only one manufacturer of the SI5351 out there?
Skyworks.
Yeah. And if those suits ever decide just to get rid of the SI5351, your projects are toast.
There you go.
You're going to go to Seed. You're going to go to Seed real fast.
during the heart of the pandemic, and I know we don't like to remember those years, but you could not get SI5351s. You could get the modules because they had a bunch of those in supply, but if you want to bare chips, they were not available.
Oh man, I'm telling you, time to go to Seed there, as Pete's been pointing out. Hey, on the mailbag, we got some really great email from Wes W7ZOI. I was telling Dean and Pete, it's just a privilege to hear from him. He's such a towering figure in the world of homebrew radio and radio in general. So it's almost like, well, it is. It's like talking to the great authors of radio stuff out there. It's really terrific. So it's good to hear from Wes. I also got emails from Jim Cook, WA1UQO. He was writing to me about the transoceanic BFO that I made for his transoceanic, but we were talking about him at lunch because we were talking about a troubleshooting project that he was involved in. I'm not going to give any further information over here on the internet. Grayson, KJ7UM. Well, it's always great to talk to the author of Hollow State Design for the Radio Amateur, a real Thermotron fan, but he has a very diverse background, because when I put the video up there about the Vintage Computer Museum that's opened up there near Timonium, Maryland, Grayson saw some piece of gear that he's been wondering about that he picked up at a dump in Turkey. And he actually picked up the phone and called the museum and got the information that he needed from the museum. So he was really, as they said, the Brits would say, chuffed about that. So really great.
Grayson's another one that has helped me as well. When I did the Hallicrafters Worldwide, he got on with me and helped me do some debugging of that circuit. So it's a great community.
Great stuff. Another guy who's really made a tremendous input to the community over the years, and that sort of we lost touch with him for a while. I'm really glad that he's back and he's doing better. It's Chuck Adams, and Chuck's, lab notebook and all the other publications and the many videos that he did, really tremendous contribution. He responded. He sent a link, or he responded to one of the videos, and I said, could that be, or maybe there's another? No, it's him. So really great to hear that he's doing well. Glad you're back, Chuck, and hope you continue to do well there. It's really great to hear from you. Hey, another guy we heard from is Frank Harris, K0IYE, the author of the book Crystal Sets to Sideband. That he's great. He's doing exactly what we were talking about before. It's in electronic form. He updates the chapters as he goes on, and it's constantly updating, constantly improving. He's even got a Spanish language edition of the book out there. So we talked to Frank. I was joking with him because I looked at his QRZ page, and there was a line in there saying that he, in his homebrew projects, he makes no use of integrated circuits at all, no chips. He also said on the QRZ page that he considers any rigs built with chips to be not truly homebrew. I said, wow. I said, I wrote to him, I said, hey, Frank, I'm with you, buddy, but realize there's only two of us in the whole world, okay?
Yeah.
And I want to know, does he build his own transistors?
Well, he wrote back to me. He wrote back and he said, oh, Bill, I'm glad you pointed that out. I was being a little bit too harsh and too extreme. He said, I will make use of chips. He said, but only if I can really like understand what's going on inside of them, which is sort of where I ended up. Like I'll use the NE602 because I figured out how it works. I'll use an LM386 because it's just an op amp, things like that. I'm not going to use any SI5351s because I don't know what the heck's going on inside that little box. Anyway.
Hallucinations.
It's hallucinating. It needs wisdom. Yeah. Got a nice email from Ed, Delta 5 Lima Papa. Ed has got some really cool antenna software that's available for free. It's on the blog. Check it out. Heard from Eldon KC5U. Eldon read about our 10 meter AM antics and decided he wanted to get in the game too. So he modified a radio that could be modified in this simple way, and then desperately wanted to make a contact. So we actually made the contact. I think he's down in Texas also. So we made the contact. Great to talk to Eldon on the band. Heard from Joe, Delta Lima 6 India Delta. Good to hear from Joe. Heard from Phil, W1PJE, our buddy up there, Phil Erickson at MIT. He's also interested in 10 meter AM, but he started to do the mod, and he ran into a point that a lot of us who've done this mod really get stuck on, because Jerry Kaufman's pages talk about doing a modification that involves tweaking L5. The problem is that on many of the boards, many of the high gain boards that we're using, there is no L5. They didn't put L5 there. So you spend a whole lot of time scratching your head looking for L5. It's not there. So I had to let him know. But anyway, Phil is going to have that transceiver modified soon. Hopefully we'll make a connection from Boston to the New York area. Let's see. Bob, WP4BQV. A very active radio amateur and is now in the United Kingdom. Good to hear from you, Bob. Heard from Dino Pappas, Kilo Lima 0 Sierra down in Wilmington. And we were talking about a very controversial topic in radio amateur world, reverse polarity protection.
Oh
man, I tell you, if you want to get into like a fist fight, just talk about your particular technique.
Diode and a fuse, Bill. Diode and a fuse.
I was talking to Dino about this. I said, as with many forms of protection, there are differing opinions about how best to approach this. Enough said. All right. So anyway, it was good to talk to Dino. Heard from Dave Richards. Dave Richards is the guy. He's had this really great blog with homebrew equipment, really fantastic photography, really great documentation. Alpha 7 Echo. Armand's receiver caught his eye, and he really was struck by the beauty of all the circuitry. Also, we get a lot of email from Roger, our buddy, Papa Alpha 1 Zulu. He always sends some great links, great stuff. Jonathan San, Whiskey Zero X-Ray Oscar. I call him Jonathan San because I was first in contact with him when he was in Japan, teaching English in Japan. He's long since left Japan. He's now up on the West Coast. And he happened to be listening to or watching the video of my contact using the high school receiver project and the 10-minute transmitter. And he heard me transmitting, and it was like the CW sounded like whoop, 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 whoop. A lot of whooping in there. And I told him, I wrote back, I said, Jonathan San, that whooping you hear, my friend, that is the sound of character. That is character, homebrew character.
And sure.
Nick N0NTV. He's done some great videos. Nick the Vic. He basically, and great minds think alike. He's thinking about notch filters just like you are.
Yes.
So he did some great videos about that. Heard from Will, Kilo India 4, Papa Oscar Victor. Will is a great home brewer, and lately he's been working on his own SSB rigs. He's about ready to achieve what Frank Harris would call the Nobel Prize in home brewing, which is, building your own SSB transceiver. Listen, I got a question out there. John West replied to one of the YouTube posts. I don't have his call sign. I don't have any way of getting in touch with him. But John said that he had a friend who is a South American ham who has, because of part shortages, has been forced to make his own capacitors for his transmitters and also make his own heat sinks by pounding out coffee cans. All right. Who is this masked man? Who is this guy? We need to be in touch with him. SolderSmoke, we need to be in touch with this guy in South America. So John, if you're listening, please send me info on who this guy is so we can find out more about this intrepid South American ham who makes his own capacitors and makes his own heat sinks. Heard from Ed, Kilo Charlie 8, Sierra Bravo Victor. He is working on his DC receiver and he's been experimenting with FETs. Pete, he's been looking for a replacement to your beloved J310, which is another one that's in short supply. Man, it's hard to get J310s these days.
Yeah, the Unity picked certainly a JFET, but I'm not sure it's will work in the HF region.
I mean, it looked to me like it was just a switch. I think he was saying that he got it to work at 7 megahertz, but we'll see. But his motivations are definitely on the way.
Yeah,
because the J310.
Well, look at the RF 510 RF device. RF device?
That's true. I know.
Yeah, RF.
Well, I was telling Dean I've switched from the RF 510 to the RD06, partly as a result of your suggestions.
Tribal knowledge tip: don't buy your RF 510s from Amazon.
Oh yeah, I know.
They don't work.
Hey, we heard from Nick, another great home brewer. November 3, Foxtrot Juliet Zulu. He provides some really good advice. I think he was talking to some of the new receiver builders. He said, be careful about trying to test or demonstrate your new receiver. Realize that very often the bands are dead, especially 40 meters. We've all been there where, it's midday on 40 on a bad propagation day, and you decide that this is a great time to demonstrate your new receiver to the visiting relatives.
Nothing.
And it's a white noise generator, and you think something's wrong with your rig, and you tear your hair out, you start probing and troubleshooting, and then you realize, no, wait a second, 40 meters was just dead.
Let me just say that demonstrating your new rig to your relatives is never a successful venture anyway.
I could do it with my nephews because they're obligated to say nice things about what their uncle has built. But anything beyond the nephew,
when their eyes glaze over, you've gone
I
too long.
know, but they put up a good front. They're good. Hey, listen, we heard Dean has completed his term as president of the Vienna Wire Society, and he has been succeeded in this capacity by another home brewer, Don, Kilo Mike 4, Uniform Delta X-Ray, owner of the Micro BITX of Life. The Micro BITX of Life, KM4. He brought it and showed it to Farhan when Farhan came here. And we brought Farhan to the Vienna Wireless lunch, and Don came and brought this rig with him.
We had to give Farhan some sedatives after he saw it. So this I call it the Franken BITX. It has LEDs.
Oh,
it has a cell phone. It has a cell phone charger plugged into it. It's got.
It mounts on his bicycle, I think.
Yeah, he can ride around on his bicycle. Yeah, it's. Yeah, and Don runs the VWS. He calls it the Weird and Wacky Digital Modes Net every Monday night. So that's if you're interested in digital modes and FL Digi, check out the Vienna Wireless Society webpage and get on Don's Net Monday night. We do it on Zoom and talk all over the world on those digital modes.
He built the simple SSB with all the LEDs in it.
He did.
The guy?
He did.
Okay.
Every circuit had an LED. He says that way I know they have power.
Excellent stuff. Hey, we heard from another great fan, a longtime fan of SolderSmoke, Dave K8WPE, and he was commenting on my complaints about the backlash in the variable capacitor out of the QF1. Dean and I have slaughtered many innocent QF1s just to pull out the capacitor. And then recently I've discovered a shortcoming. There's some dead space in the center of the tuning of the thing, the reduction drive, the planetary gear drive that they have in there using ball bearings. either it starts out not too good, but over time, over 50, 60, 70 years, it doesn't get any better. Dave was criticizing me for complaining about this. He said that, he basically implied that I'm going soft when I want, I object to dead space. I should be living with dead space. I should accept it. It's just part of the difficulty of tuning a homebrew rig. Okay, Dave, I hang my head in shame. I heard from another Dave, a good friend of mine, WA1LBP. Dave is my fellow ambassador. He was in Okinawa when I was in Santo Domingo, and we were both ambassadors of 73 magazine. We were both in the Foreign Service. We joked this was our only chance to being ambassador of any kind. So it's worked out. And I wrote to him because there was a recent story that made the rounds of a sergeant in the Marine Corps out in Okinawa who has a pretty impressive workshop in his home quarters. I mean, that was pretty good. That got me to write to him. Heard from our old friend George Zaff, KJ6VU. They recently celebrated the 200th anniversary of their podcast. So congratulations to George and all the folks from Ham Radio Workbench. Great stuff, and congratulations on the 200th anniversary. I was going to show up for that, but I had medical problem. My back was killing me. I ended up talking to the doctor. Anyway, it's all worked out, but sorry I missed the event there. George, congratulations. And finally, a local ham here, Bob, KD4EBM, a man of many talents and many interests. He also repairs the watches of astronauts, the Casio watches that astronauts have taken with them into space. And this got me to think about this watch here. This is a watch that Elisa bought for me back in 1993. And it kind of died. It's an old Casio watch. It's got an altimeter, a temperature sensor, and a geomagnetic compass inside this thing. 1993, not bad. He told me how to get it working. So I replaced the batteries. I shorted out some terminals. Boom. Bob was my uncle. The radio's working. Thank you very much.
What's on your other wrist?
Huh?
What's on your other wrist?
The other wrist is this one I have to keep on because this one is connected to the internet. And our buddy George at the Vienna Wireless was saying, a man who has two watches never knows what time it truly is. And then he stopped and he said, unless one of them is an Apple Watch, and you definitely know what time it is because that's the time. Hey guys, this is great. Listen, I'm really glad that Dean got to join us this time. Dean is a for real technical wizard. I mean, he kind of said that he's only been in the homebrew game for a few years, but he's made amazing progress. And it's based on the fact that he's got long involvement at very high levels in the whole software community. He's helped me when I ran into software problems with my internet service provider. He came right over and got it squared away. So it's really great to have him with us. So anyway, what do you guys, any final comments, Pete?
Yeah. I want to just make a comment about Okinawa.
Okinawa.
Yes, I spent time on Okinawa, and it's a wonderful island as such. And we had a ham station there. I was with Mobile Construction Battalion 10, and our call sign was KR6 Sugar Baker for CB. KR6 SB was the call sign there at the station at Camp Kinser in beautiful downtown Okinawa near Naha. And some wonderful times there, wonderful people. It was just a great place to be. Great place.
Dave, who I just mentioned, was our vice consul at Naha at the time that we were ambassadors. And my nephew Daniel is in the Marine Corps. He's a captain in the Marine Corps. He's in Okinawa right now. So yeah, it sounds like a really interesting place, blue zone place. They live great lives out there at Okinawa. Dean, any final comments?
No, just thanks for inviting me, guys, and really fun to join you and being your friend. I've never been called Jazzy before, so that's nice.
You definitely jazzed it up, don't you think?
Oh yeah, absolutely.
He jazzed it up, man. Yeah. Jazz it up, yeah. All right, okay. 7-3 from Northern Virginia, from Falls Church in Northern Virginia.
7-3 from Great Falls.
And 7-3s from the left coast.
See you guys. Ciao.
Bye.